Welcome to the first unit of Chapter 7 and the first chapter of our second trimester of flipped algebra. Just to review this first slide, table of contents, each section that we do for the chapter, we'll just add on each section onto the table of contents. This will always be the first slide of your intro videos, and so for your own note-taking, you can have the first page of your notes be the table of contents. Off to the side, you can put today's date, and then over here on the right side, you can keep track of what page this is in your notes. All right, for 7.1, we are looking at integer exponents. So this whole chapter is on exponents and their properties. This first table right here, this just gives us an idea of how exponents work, positive exponents all the way down to negative exponents. So you do have two parts to this expression. If you look at 2 to the 4th power, this 2 on the bottom, that's called a base. So it's a base of 2. We're raising it to the 4th power. That's our exponent. That means what they're saying to do is take 2 and you multiply 4 of them. So 2 times 2 times 2 times 2 gives us that 16 right there. So if you just continue on down the table, 2 to the 3rd power is just 3 of them, 2 times 2 times 2, which is 8. 2 squared is 4, and now we can keep filling in the table. 2 to the 1st power is just 2. And when we get to 2 to the 0 power, this is our property we're going to talk about down in the bottom. 2 to the 0 power is going to equal 1, and if you notice, we have created a pattern in these numbers right here. 2 to the 4th, 2 to the 3rd, 2nd, 1, you have 16, 8, 4, 2. The pattern to get from one number to the next is we keep dividing by 2. So 16 divided by 2 is 8, 2 to the 3rd. Divide by another 2 is 4. Divide by 2. So if you're going from 2 to the 1st to 2 to the 0, you just take the 2, divide it by 2, and that's how we get that 1. If you take, now see how for the next one, you're going just to the negative 1, so you want to divide by 2 again. So you take the 1 and you divide it by 2. Now 2 to the negative 2 power, if you take 1/2 and divide it by 2, you actually get 1/4. And 2 to the negative 3rd power, divide that by 2 and you get 1/8. So we could continue if we said 2 to the negative 4th, following the pattern we have up here. I know it's going to be 1/16. But there are some properties to help us out. The first one is right here. So what we're saying is a to the 0 power, so a base of a. It doesn't matter what this is. It could be, 10 to the 0 power, 500 to the 0 power, -3 to the 0 power. This property tells us that any number raised to the 0 power will always equal a 1. So 10 to the 0 power is 1. 500 to the 0 power, 1. -3 to the 0 power, 1. So that's a nice easy property to have. We just have to remember that anything raised to 0 power equals 1. The second property we have is a negative exponent. So whatever your base is, your base of a, if you raise it to a negative exponent, you do end up with a fraction. You do 1 over a to the positive n power. The way I kind of think about it is if you need to make an exponent positive, here, maybe I'll write over here. Let's say we have 2 to the negative 3 power. I like to think of it as a fraction, and then I know that the negative exponent with its base has to go down here. So that 2 stays the same. That brings it to a positive power, and you have to leave a 1 up there because there's nothing else up there. So this negative exponent property, we'll get the hang of that if that seems a little bit weird right now. But those are the two properties we're going to focus on for this section. So here are some 0 exponent examples. So 5 to the 0 power, well, that's going to equal 1. M to the 0 power, n to the 0 power. Well, m to the 0 power is 1 times, because that's multiplication between, n to the 0 power is 1, and 1 times 1 is 1. So not bad so far, right? Then we get down here, and you just want to be careful with what actually has the 0 exponent. So this 0 exponent is only tied to the x, which means the 4 stays. So it's 4 times, and then what's x to the 0 power? 1. 4 times 1 is 4. So we did have the 0 exponent in our problem, but our answer didn't end up as a 1. like the other two examples because we had that 4 out front. Now this next one, you see the 0 exponent, so we know it's going to equal 1, but just again think about what is the base with that exponent. The only thing raised to the 0 power is the y. So that means the x didn't change, so it's x times y to the 0 power is 1, and x times 1 is just x. All right, let's look at some of the negative exponent examples. So once we get the hang of these, they won't be too bad. Again, I like to make a fraction, and then I say, well, here's my negative exponent with its base. So to make that exponent positive, it has to move. If it's in the top, it moves to the bottom. So in the bottom, this is going to become, the base never changes. It's going to stay as a 6, but instead of a -2, it becomes a +2. And because there's nothing left on the top, over here, the exponent and its base move, so there's nothing out front. We're just going to leave a 1 in its place. So 1 over 6 squared. And then from there, we can say, well, we know what 6 squared is, so let's go ahead and say 1 over 36. That will be our final answer. All right, next one, I see m squared n to the -3. So again, let's think about it like a fraction. And the negative exponent can't stay negative, so the negative exponent with its base has to move. It's in the top, we're going to move it to the bottom. So what you want to look at is, does everything move to the bottom or just the part with a negative exponent? And it is going to be only the part with a negative exponent, so that m squared stays there because that was a positive exponent. We didn't have to move it. And then when you move the n to the bottom, that changes the sign of your exponent. That will become a +3. And there's nothing else we can do with that, so that one is complete. All right, next one we have 3 to the -3rd. So there's my fraction. I take the negative exponent and the base it's attached to. That has to move down here. It was in the top, so it'll move to the bottom. That becomes a +3, and there is nothing left up top, so that's when we put the 1 right there. And then we say, well, 3 to the 3rd is 3 times 3 times 3, which is 27. Be careful with your exponents. Some people will tell me that 3 to the 3rd power equals 9. And if you think about, well, why would they say that? Because it's really easy just to take the 3 times the 3 and get 9. But you have to actually multiply the 3 times 3 times 3. All right, our last example looks a little bit different. You can see we do have our negative exponent with our base of x, but this time it's in the denominator of your fraction. So regardless of where it is, whether it's in the top or in the bottom, it has to move. So if it was in the top, it comes to the bottom. If it's in the bottom, it has to go to the top. So now on the top of your fraction, you have the 1 times, when it comes up, it's multiplication in between. Now x to the -2, the base stays the same, and that becomes a +2. What do you have left in the bottom? Nothing, so you can put a 1 there, and then that looks just a little bit weird, like we could simplify that. 1 times x squared is x squared, and x squared over 1 is just x squared. So we can go ahead and say x squared is our answer. All right, here's our last slide. We're just going to do these two examples. What we're doing here is just substituting in numbers for our variables and then simplifying, but all of our examples will involve exponents. So simplify 8 minus n to the 0 power. So all we have to do is plug in the 10 for the n. And yep, so never mind, keep going. 8 minus 10 is a -2 to the 0 power. And then what's anything raised to the 0 power? 1. So that final answer is just 1. Oh, look at that. I had one down there. How nice. All right, now we're to our last two problems. All right, so we're going to do 7 times, instead of the x, we know we plug in a 2 for the x to the -2 power. Our y is a -3 to the -3 power. Now, before we do any simplifying, we have to take care of these negative exponents. So again, kind of picture it like a fraction. What has the negative exponent? First, look at that 7. Does this 7 have a negative exponent? It does not, so the 7 is going to stay on the top. Then the next one is 2 to the -2 power, so this is going to come down here. your base stays as a 2, but that negative 2 becomes a positive 2. All right, then we go to the next one. This negative 3 to the negative 3 power, that has to come down here also. Now, do you see how your base is a negative 3? That base does not change. That stays as a negative 3. What does change is your exponent. That becomes a positive 3. All right, so when we simplify, the 7's good on top. On the bottom, do we know what 2 squared is? So that's 2 times 2, which is 4. And then how about negative 3 to the third? That's saying to multiply negative 3 times. So negative 3 times negative 3 is a positive 9, times one more negative 3 is a negative 27. All right, so simplifying this, all you have to do is top is 7 on the bottom. What is 4 times a negative 27? It's a negative 108. And then see if that reduces, which 7 does not go into that, so that'll be our final answer. All right, last one. Yes, it's a fraction, but that's okay. We can handle it. We're in Algebra B now. So again, just plug everything in first. You have 4 times your m. Oh, look at that. Let's make this m, make this n. 4 times a third times our n is 6. This whole thing is raised to the negative 2 power. So what might be nice is see if you can simplify the inside before you deal with that negative 2 exponent on the outside. Because it's multiplication, you can multiply this in any order. I would multiply the 1/3 times the 6 first. That's like a 6 over 1. If you multiply straight across, you get 6 over 3, which is 2. So really we're looking at 4 times 2 to the negative 3rd power. Sorry, negative 2 power. And then keep simplifying. 4 times 2 is 8 to the negative 2 power. All right. Now that we have our base simplified, it's just an 8. Remember your exponent and base move to the bottom. There's nothing left on top, so 1 over the 8 stays the same. It becomes a positive 2. And 8 squared, 8 times 8 is 64. And that's 7.1.